Okay, so let's get started. We're going to be taking a look in this training module at understanding how to tune out IPC wheel torque errors in our Gen 3 engine control module. This is super important that we get this under control. We want to have the internal plausibility check, known as IPC, in place so that we don't have a potential runaway throttle situation or a situation where we're delivering way too much torque for what we've requested from the driver demand table, which is the beginning of where we have our pedal input and a torque request. We want what the engine is making in torque to line up very closely to the driver demand table. If we ever overstep from that, we're generating IPC torque errors. That means that we have an imbalance or calibration problem in our speed density tables or in our torque and inverse tables. So there's something going on that's creating an imbalance or a problem. We're going to learn how to calibrate and tune this. So we talked about the basic and fundamentals in the last tutorial. This tutorial, we're going to dig in here and make sure we understand how to actually correct the problem. All right. So we have a couple different ways we can correct things. I'm going to show you with some sample files paired to sample data logs showing the calibrating and tuning process. So instead of sitting on the dyno and filming and going through and starting and stopping and going through the process, I just save the logs, I save the calibration files paired to the logs so we can open them up simultaneously and look at what was changed and look at the data log and see the cause and effect and really narrow down and have a concise way to take a look at correcting this problem. All right, so let's open up the first file here. This is the baseline file. This is what we're starting with for my demo vehicle. And I was generating a ton of IPC wheel torque errors that we're going to find for the paired data log here in just a minute. But let's go ahead and open up that file. Let's go to File, let's go to Open, and we're going to move into our HBT Gen 3 course folder. We're going to move into the sample data log subfolder, and then from there, the torque table tuning subfolder. We have a couple different calibration files that we can select in here. We're going to be working with the very first one, custom VCT schedule, intake manifold runner control, delete JLT intake. So my demo vehicle here is going to be getting an ESS supercharger, which we will be filming on the vehicle, and we're going to be including that in the training course, hopefully when it's released. If not, it'll be included in the near future. In preparation for the supercharger kit, I've done the intake manifold runner control delete to the GT350 intake manifold that comes factory on this vehicle. So I've prepped that ahead of time. I'm also running my custom VCT schedule that we've talked about in previous training modules. In this case, the torque and inverse and speed density tables are thrown out. They're not going to be valid anymore, and we actually have to calibrate and tune for them. So we're going to be taking a look at what we need to do in order to calibrate either set of tables to get our system back in line so we're not generating IPC wheel torque errors. All right, so let's go ahead and open up this file. There are two things that I want to point out in this file before we go any further into the training course. Let's go ahead and open this up. And we're going to first move in from our engine tab over here to our torque management, under our torque model. We're going to be moving into monitoring. And under here, I wanted to point out that I've raised the wheel torque error max value to 1 million, which is the highest that we can place in here. What this is saying is we're raising up the ceiling or the limit of what the system's going to look for the IPC wheel torque errors as they're generated. If we've raised it up to 1 million, we've essentially turned off the torque monitoring system. While that's good for calibrating and tuning, long term we want to put the value back to the previous stock value that Ford has calibrated and put into the scalar value here. That would have been 40,000 for my particular operating system, all right? So I've raised this up to 1 million on purpose, just temporarily, so I can go through and calibrate everything, and then I'm going to put the value back in place so I have the torque monitoring system still working for me. I don't want to go and turn it off. A lot of tuners do this, which is lazy and also dangerous. We don't want to do that. We want to do things properly. So we're raising up the limit right now to 1 million. The other thing I want to go and talk about here, before I show you a driving log associated to this file flashed to the vehicle, is also something that I did not talk about in our last tutorial. If we go to airflow, we go to electric throttle. I wanted to mention here that the torque system in our Gen 3 control modules is a closed loop system. So it's going to be constantly trying to adjust the throttle angle so that it's matching what we're requesting from our pedal. So throttle and torque are going to be translated in the background calculations. For a given pedal input, we get a given torque request. It translates the torque request back into a plate or throttle blade movement. So essentially we're translating blade movement to pedal movement in a closed loop format. But at a certain point, we come out of this closed loop system and the IPC wheel torque errors will be ignored. That's all driven and controlled based here on our pedal position watt start, pedal position watt end. This is saying here, above this particular pedal position, we're gonna start transitioning from closed loop to open loop control. And then once we reach 90 here, that's gonna be fully going into wide open throttle operation, at least the way that they're translating this. We're gonna talk about what these numbers actually mean here in just a brief second. But this is gonna be saying that above 90, it's gonna be completely ignoring any of the closed loop feedback and it's gonna run purely open loop. So essentially gonna be ignoring any potential adjustments that can be made in the system. So above 90 in our pedal position, we're gonna find that we're riding without the IPC wheel torque. So we're not gonna have that in place and we're riding purely in open loop. Now, what's important to note about this...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.